Okay, there we go. Okay, so 2-1, we're doing a lesson where we're dealing a little bit with equations and inequalities. So before we get started with that, we're going to do a little review here. This says a robot submarine dives 803 feet to the ocean floor. Then it rises 215 feet as the water gets shallower. Then the submarine dives 2,619 feet into a deep crevice. Next, it rises 734 feet to photograph a crack in the wall of the crevice. What is the location of the crack in relation to sea level? So it's dealing with positive and negative numbers. So we're going to just go ahead and write this out. So if the submarine dives 803 feet, what type of a number would that be? Negative. So we're going to put negative 803. Okay, and then it says that it rises 215 feet. So we're going to then put
plus 215.
Very good. And then it says that it dives 2,619 feet. So we're going to write
Minus 2,619.
Whoops. And then it rises 734 feet.
Plus 7.
Okay, good. All right, now we need to calculate that. What would be maybe a good method for calculating this that might kind of help us? Isaiah?
Do it, combine the two negatives and combine the two positives.
Sure. If we add these together and then we add these together, that will make things a little easier because they're like signs, so you can add them up. So add up the negative 803 and the negative 2,619, and let's see what you get.
3,022.
Negative 3,422. Okay, now add up the 215 and the 734.
949.
Okay, so, and that's a positive 949. So what are you going to do with those two numbers?
Subtract 949 from
3,422, yes. Subtract those, find the difference there.
Negative.
Negative 2,473. Do you guys agree?
Yes.
Okay. All right, good. All right, that's just a little starter here to get us thinking about negatives and positives. Let's go ahead now and look at the next section where it says to tell whether the given number is a solution. All right, if you look here, this is the number they're talking about. It's right after that semicolon. They're wanting to know, is that a solution to this equation? Okay, so that is the number we're going to plug in right here. So 3b means 3 times b. All right, so 3 times, if b is negative 7, we're going to put that right here. And then bring down the minus 8 and the equals 13. And we need to work out that left side of the equation. So 3 times a negative 7 would be a negative 21. And we still have that minus 8 equals 13. Bring all of that down. Now you need to figure out negative 21 minus 8. What would that be? Negative 29 equals 13. Okay, so does negative 29 equal 13?
No.
No, it does not. We're going to put a slash through the equal sign that says negative 29 does not equal 13. And so therefore, we're going to write no, negative 7 is not a solution to this equation. No, it is not a solution. Okay, number 2. Let's try this one. Plug in negative 2 in for x. So we've got negative 4 times negative 2 plus 7 equals 15. Negative 4 times negative 2 is 8 plus 7. 8 plus 7 is 15. Do the sides match up? Yes. So I'm going to put a little check there, and I'm going to write yes. Negative 2 is a solution to that equation. Yes, it is, because when we plug it in, the sides end up equaling each other. Okay, let's do number 3. Plug in negative 1 for f. So we have 12 equals 14 minus 2 times negative 1. Bring down the 12 equals 14. Now, be careful here. What do you think I should write? Plus 2, because that's a negative 2 times a negative 1, which is a positive 2. So now we have 12 equals 16, and that's not true. So we're going to put no. Okay? All right, let's look at number 4. Bring down the negative 6 equals 14 minus 11 times 2. Negative 6 equals 14 minus 22. Negative 6 equals, what's 14 minus 22?
Negative 12.
No.
Negative 8.
Negative 8, right? And that's not true, so we're going to write no. 2 would not be a solution then. Okay, plug in your 3. 7 times 3 minus negative 5 equals 26. 7 times 3 is 21. That's really, a minus negative is really like a plus 5 equal to 26. 21 plus 5 is 26. So the sides do match up, so we're going to write yes. Okay, let's plug in negative 1 here. 25 minus 10 times negative 1 equals 15. 25, what? Plus 10.
Wait, why are we doing?
Because a negative 10 times a negative 1 is a positive 10. 25 plus 10 is 35. Does that equal 15?
No.
No. So we write no.
No.
Okay? Number 7, plugging in 1. Negative 8 times 1 minus 12 equals negative 4. I'm going to do these last 3 on my own here. You do them on your paper, and then you can check them with me. I'm going to work them. I'm just not going to talk through it. Okay, you can check. I've got this worked out up here. I did the simplifying in blue. Whenever you're multiplying fractions, you can simplify numerators with denominators, and that makes it a little easier. Okay. Are we any questions on 4, 5, and 6? Okay. Just one moment. I have a video going here for just a minute. It's okay. Okay, guys, I want you to go ahead and try to set up and solve 10 and 11, and then I'll come back with you. Are you guys getting that set up?
Yes, ma'am.
Some of you. Let's look at 10. The difference of a number and 7 is 8. How do you write the difference of a number and 7? Okay, and then is, so we put equals 8, and there you go. That's it. Pardon? What do you don't know the solution yet. Okay, number 11 says 6 times the sum of a number and 5 is 16. Do you know? Okay. 6 times the sum of a number and 5 is 16. So how might we write that?
6x plus 5 equals 16.
6.
Did you get it right?
6 times the sum of a number and 5. Yes.
6 minus 10 times 6 plus 5 equals 16.
Yes. That's what I'm looking for right there.
Wait, why does it have to be in parentheses?
Because it's saying 6 times the sum. So the sum means you have to add two things together.
That makes sense.
So they would need to be added together before you would multiply it by 6. Does that make sense?
Yes, ma'am.
Okay. All right. Number 12. A computer programmer works 40 hours per week. What is an equation that relates the number of weeks, W, that the programmer works and the number hours, H, that the programmer spends working? So we're using W and H. Stop and just kind of think about that one for a minute and see if you can come up with an equation. Anyone have an idea? Isaiah?
40W equals H.
Yes. 40W equals H. 40 times however many weeks you work will tell you how many total hours you have. Good. All right, 13. Josie is 11 years older than Macy. What is an equation that relates the age of Josie and the age of Macy? Josie's J and Macy's M. Harley?
M plus 11 equals J.
M plus 11 equals J. Okay, that would be one option. Liam?
11 plus M equals J.
You could switch it around and use the commutative property. Kate?
J minus 11 equals M.
Yes, that would be another option. This would be your two options. Okay, flip your lesson sheet over. Now this 14 and 15 says, tell whether the given equation has the ordered pair as a solution. Okay, so remember when you were graphing coordinates, you had an x and a y? So now we're going to plug in two numbers here, but it's still pretty simple. So in place of my y, I'm going to put -5 equals, I'm just copying this down, then I have a 3, and then it's 3x. So 3 times x is -1 minus 2. So all I did is I wrote down this right here, this problem, but in place of the y, I put -5, and in place of the x, I put a -1. Yes?
How do you know that -5 is what?
Because it's a coordinate plane, and whenever you're plotting points, you always have your x and your y. Yep.
That makes sense.
And it says in the directions ordered pairs, so when it says ordered pairs, we know it's talking about an x and a y.
Okay.
All right, so then we bring down our -5 equals 3 times -1 would be -3. 3 minus 2, so negative 5 is equal to negative 5. So that's true. So yes, negative 1, negative 5 would be a solution for that equation. Okay, let's do the same thing with 15. So we have our x and our y. So in place of y, I'm going to put 7 equals 13 plus 6 times negative 1. Bring down my 7 equals 13 what? You can write plus negative 6 or you can just write minus 6, either way. But you can't put minus negative 6. It's either plus negative 6 or minus 6. 13 minus 6 is 7, so this one worked as well. Okay, the next section is on inequalities. Remember, inequalities are the less than sign, the greater than sign, the less than or equal to sign, and the greater than or equal to sign. 16 says A is greater than 4, so you have to know which way to put your sign. Hopefully you know it goes this way, greater than. 17, C is less than or equal to negative 2. Less than or equal to, so it gets the little bar under it. And a less than sign, look here, when you take a less than sign and you open it up so that it looks like this, it makes an L. So that's how you can remember less than. L for less than, and a less than sign looks kind of like a smushed L. This is not a smushed L. Okay, we don't make our L's going that direction. Okay, 18. M is greater or equal to 1. Greater than or equal to 1 and less than 2. So there we go. Those are pretty easy. All right, now we're going to do the same thing with the inequalities here. We're going to plug in a number for x and see if this inequality is true. So we're going to take, here's the problem, and they're wanting us to check this as a solution. So we're going to plug that in for x. So we have, instead of 2x, we're going to have 2 times 2 plus 4 less than 20. What's 2 times 2? 4 plus 4 less than 20. 4 plus 4 is 8 less than 20. So stop yourself and say, is 8 less than 20?
Yes.
Yes. So the answer is yes. 2 would be a solution to that inequality. All right, let's try 10. 2 times 10 plus 4 is less than 20. 2 times 10 is 20 plus 4 less than 20. 20 plus 4 is 24. Is 24 less than 20?
No.
No. So also put a slash through that sign because that would not be right. Okay, our last two, we have to write an inequality here. Number 21, no more than 10 people may use the treadmills at any time in the gym. No more than 10 people. So we have to also define our variable. That means tell what the variable stands for. So what do you suppose the N would stand for? The number of people, right? On the treadmill. All right, so how could we write this then? No more than 10 people can use the treadmill at any given time. Yep, that's right. Very good. N would have to be less than or equal to 10. Okay, number 22. To train for a marathon, a runner decides that she must run at least 12 miles each day. Let D equal the distance that she's running. Okay, and so what would this one look like?
It would look like
Harley?
D has to be greater than or equal to 12.
Very good. D would have to be greater than or equal to 12. Very good. Is that the last one on your notes?
yes.
Okay, let me go ahead and get this